And we're going to start out with slope. So there are 4 different types of slope that we can have before we go through the equation and doing it on a graph and stuff. So we have 4 different types, and y'all are going to help me out to determine which is which. So we're going to draw 4 graphs. This last one's straight up and down. It's just kind of hard for me to draw that. I always make it a little bit slanted. There are 4 types of slope. I'm going to write the 4 types over to the side, and what I want y'all to try to do is I want you to try to match what it is with the graph. So right underneath the graph, which type of slope you think it is, okay? So remember, slope refers to how steep the line is. There can be a 0 slope. There can be a positive slope. There can be an undefined slope. And there can be a negative slope. So what I want you guys to do is match which one goes with which picture. So which one do you think is the 0 slope? Which one do you think is positive? Which one is undefined? And which one is negative? Remember, slope is how steep the line is, or the incline of the line, if you're, or like of a mountain or a hill, or if you're walking. So write down what you think is which. And look straight in the camera when you're done. And remember, all our cameras need to be on. A few of you logged on, but then you didn't do the formative assessment. So that pretty much tells me that you're not there, that you are not actually sitting there. So I need to be able to see that you are here paying attention and sitting at your computer. Terica, I know that you are there if you need to have your camera off so that you can actually watch this. Your internet's going really slow. All right, so I need to be able to see everybody. All right, so let's see if we can match these up correctly. Who wants to give me their answer for the very first one?
Positive.
Positive, good job. That line is going up from left to right, so this is our positive slope. So that would mean that our next line would have to be the
Negative.
negative. Good job. I think of positive as I'm climbing the hill, I'm walking up it. Negative, I'm sliding down a slide. Okay, so from left to right, going up, then going down. All right, our next one. What do we think our next one is?
0.
Good job. There is no slope. If you were walking across this, there would be no incline, there would be no decline. You were just going straight across. And our very last one.
Undefined.
Undefined, right? If you are coming across something that looks like this and you're on a hike, there's no way you're getting up it. You're running right into a wall. That is undefined. We have no slope at that point whatsoever. I mean, it's undefined, doesn't exist really. Okay, so those are our 4 types. Now we're going to start to calculate what it actually means. How do we get the technical slope between 2 points or of a specific line? So here's our slope formula, and y'all will remember this. M equals y2 minus y1 over x2 minus x1. Raise your hand if that is familiar to you. All right, good job. Good. So this, you might have also heard this called rise over run. This just means How is the y changing? That's your rise, your up and down. How is your up and down changing over what happens left and right? So the up and down is on the top, the left and right is on the bottom. So let's just look at a graph and see if we can calculate the slope just going between 2 points. So that crosses at -2 on the y-axis and 3 on, or switch that, -2 on the x-axis and 3 on the y-axis. And we're going to count our slope. The first thing we need to remember is this going to be a positive, negative, 0, or undefined slope? What do we have going on here?
Positive.
It's positive. So in our answer needs to be positive. So if you calculate this and end up with a negative answer, you did something wrong, okay? But this is going to be a positive answer. So we start from the leftmost point that we see, and we're going to see how much we have to go up and how much we have to go over. So we are going from here to get from this point to this point, we have to go up 1, 2, 3 units. So 1, 2, 3 units up. So we're going 3 up and 3 down. Just kidding. That's a softball cheer if you ever played softball. And then we're going how many over? 2. So we go over 2. 1, 2. So 3 up and 2 to the right. So our slope is 3 over 2. We went up 3, that's why it's a positive 3, and we went right 2. If we were going down instead of up, our number on the top would be a negative number. So if you are going down, the number on the top is negative. That tells you you're going down. Okay? So positive, our line's going upwards. Negative, our line would be going downward. So if you see a graph, you're just going to count. Now we're going to look at 3 where we've got ordered pairs. And we're going to calculate using our slope formula. I'm going to write the 3 examples down and we'll work through them. So we're going to find the slope between these sets of points. And if you're still new at doing slope or you've forgotten, it's very helpful if you write the x1, y1, x2, y2 on your points for you to identify where you need to put the things in your equation. Oh no, don't mess up. Wrong one. Okay, so I'm just going to write it on the top of the very first point, and then I'm not going to copy it again. So this is my first x and my first y, so that's x1 and y1. And then I've got my second x and my second y, so x2 and y2. Everybody okay labeling the points? First x, first y, second x, second y. Okay. So now we're going to plug those points in the right spot in our slope formula, and it's going to tell us how much up and down our graph is going versus how much left and right it's going. So remember, I'm just going to rewrite the formula one time here so you know where these numbers are coming from. So y2 minus y1 over x2 minus x1. So when I say a variable, I want y'all with your hands to tell me like which number needs to go there, okay? So for my x2 position, which number needs to go in the x2 position? So hold that up, look at where, no, sorry. Hey, we don't start with x2, we start with y2, but y'all got x2 right. What goes in the y2 position? Where are we starting with? y2 is 1, we start with y2. What is y1? 5, good. Yeah, you have to send an attendance note to the attendance office. Just send a note. Okay. All right. And your x2, 3 minus, and your x1, -2. Okay, so we put the numbers in the right spot, and now we're just going to subtract. 1 minus 5 is -4. 3 minus -2 is 5. Everybody okay with that? Okay, show me with your arms how this line is going to be looking. Is it going to be going up? Is it going to go down? So go with your arms. What would this line look like? It would be going
Down.
down. Yeah, y'all are trying to, and everything's reversed from what I can see. So this, I look like that's going, does that look like it's going up to you? To me, it looks like it's going down. So it's everything's just reversed on here for that. So we know this line's going to be going down. We go down 4, we go right 5. Down 4, right 5. All right, let's try the next one. M equals, what's our y2?
5.
5, good. Y1?
5.
Okay. X2?
3.
And X1?
7.
7. 5 minus 5 is 0. 3 minus 7 is -4. If you have 0 things and you try to divide it by -4, we still have 0 things, right? 0 divided by anything is still 0. So what does a line with a 0 slope look like? Can you show me with your arms? A 0 slope is, good, straight across. A 0 slope does not have any y change. It does not go up or down. If you notice the y values, they stayed the same. We were at 5, and then we went to 5. So we didn't go up or down for our y value at all. That's why our slope is straight across. Okay. All right, I want you guys to try the last one on your own, and we'll see how it goes. So go ahead and do your slope for the last one. When you've got it, show me your paper. Good job, Ernest. And Alexis, y'all are working ahead. And Madison, It's blurry, Reggie. Thank you, Destiny. And Noah, awesome. Oh, Mallory, look at your denominator. You have to do a minus in between both those numbers. Morgan, good job. It was just a negative error. Kelsey, good job. Brian, Reggie, so close. Look at your denominator. Isaac, yes. Braden, good. Braden, the fraction is good, but then you'll notice something about what the answer is. So you jumped one step ahead, but I'll explain it to you in a second. All right. Miley, the x's go on the bottom. Did you have your x's on the bottom and the y's on the top? Okay. Yeah, the y's are on the top. All right, Gabby. Gabby, make sure that it's -2 minus -2. You forgot the negative in the front from the x2. Same thing with you, Deja. There's some negatives in the denominator. Yes, Molly, you got it this time.
Wait,
good job. All right, so let us work through this one and see what it is. Our y2 is 5. Our y1 is 3. Our x2 is -2. Our x1 is also -2. So 5 minus 3 is 2. -2 minus -2, remember our negatives make a plus plus, and that's going to be a 0 in our denominator. All right. Can you divide by 0?
No.
No. If you're trying to divide by 0, we will always say, not going to work. That is going to be undefined. So if you get a 0 in the denominator, it is undefined. Okay. So what does a line with an undefined slope look like? Can you do that with your arms? Undefined slope? Just like this, right? Undefined slope. Okay, good. So if you have a 0 on the bottom, you know that we had no changes in our x values. Those stayed the same. Our x values stayed the same. So we didn't go left and right at all. So those are our slope problems. Now we'll move on to slope-intercept. We're going to write in slope-intercept form, graph from slope-intercept form, and then put something in slope-intercept form.
What did I miss? My computer went dead.
I think we just did the last slope problem. Okay. I'll keep it right there for you. Does somebody want to be brave and tell me slope-intercept form? Do you remember it?
Remember it, but I don't know how to do it.
X plus B.
Y equals mx plus b. Yes. Good job. So slope-intercept form is y equals mx plus b. This is an easy form for us to graph from because it tells us where to start and it tells us what to do once we are in our beginning position. So our m, obviously, we've been using it this whole time today, stands for our slope. And our b, not so obviously, stands for the y-intercept. And your y-intercept shows on the graph at the y-axis. It's where the line crosses the y-axis. That's one problem that I see a lot. People they think it's the x-intercept instead of the y-intercept and put their starting point there instead. Kobe, do you still need that slope problem or you get it? Okay, good. So they're going to give us a slope and they're going to give us a y-intercept. And we're going to write it in slope-intercept form, and then we're going to graph that equation. So we want to write the equation with a slope of 2 and a y-intercept of 3. And once we write that, then we're going to graph it. So this will be a good reminder of how to sketch a graph given your function. All the problems you're going to do today, they're going to give you the slope and the y-intercept. You don't have to solve for that in the equation part of it. We'll do that next time. All right, so we have the m, we've got the b. Let's just plug it in. Here's our equation. Y equals 1/2 x plus 3. What do you think about that? Pretty good? Thumbs up if this makes sense, if we're getting it. We got our M, we got our B, we plug them in. Bada bing, bada
What
boom.
about the X?
The X just stays an X. You have to have that in your equation so that if you're plugging numbers in, you've got to have the X to plug it in to get a Y value. Like if I wanted to know what it was at 2, I could plug 2 in, it would give me the Y value. Okay. All right, now we're going to graph it and see what this looks like on our graph. I'm going to do 5 in every direction, 5 tick marks. Our y-intercept is always our starting number. This tells us where we're going to start on the y-axis. So we look at our b value. This is going to be our start, and it's on the y-axis. Okay? The slope tells you how do you get your second point. Once you know where to start, where am I going to put the second point? Okay, so this is going to give us instructions for our second point. So we're going to graph this one together, and then I'm going to give one for y'all to try. Okay, so if we are doing this, we are starting at which number? 3 on the y-axis. So go ahead and make a point at 3 on the y-axis. That's our first point. Okay, and then our slope is going to tell us how do we get to our next point. So our slope is 1/2. All right, so if we're thinking about it, the top number tells us if we're going up or down and by how much. That's okay. And the bottom number tells us how much we're going to the right. So we've got up 1 and right 2. Why is it up instead of down? Can anyone tell me?
It's a positive, not a negative.
Positive, right? So we know we're going up. So, all right, go to your point. We're points on 3. We're going to go up 1 unit and right 2 units and put our second point. So from 3, up 1, right 2, and put our point. And we connect them to draw our line. Okay. So it's our starting point. We start at 3 on the y-axis, and our slope tells us what to do next. Up 1 over 2. All right, here's one I want you to try on your own. Do the exact same thing. I want you to have a slope of -3 and a y-intercept of 2. So write your equation and then sketch your graph. Oh, first, do y'all remember what to do if your slope is a whole number? If you're thinking about how to move over, you have to make it a fraction. So how do you make a whole number a fraction?
-3/1, I'm guessing.
Yeah, -3/1. So when you're talking about how to move, when you're doing your graph, it's going to be down 3 and right 1. Okay, so you'll have to think about that. M equals -3/1 when you're sketching your graph. Down and then right. So make your equation and sketch your graph and then let me see it. Yep, Ernest.
Miss Roselle.
Who is that? Yes, Mackenzie.
So was we supposed to turn in our last class notes with our homework from last class?
Yeah, but if you had the assignment, I just gave it to you this time. But you can turn it in if you want to.
I was about to say I turned in the homework, but not the notes.
Yeah, that's all right this time. Alexis, thank you. Madison, thank you. Good job. Make sure you're writing the equation too. So write the equation and then graph it. Brayden, good job. Mallory, good job. I can't see your equation, but the graph looks good. Destiny, make sure you go down 3 and right 1. I think you went down 3 and left 1, so go to the right. Same thing, Morgan, down 3 and right 1. Your line needs to be slanted downwards. Deja, your graph looks like it's going in the right way. It's a little bit blurry. Kobe, you want to be at +2 on the y-axis, +2. I think you swapped those. All right, Brian, we're at +2. Now go down 3 and right 1. You didn't go left or right any, so go down 3 and right 1. Okay, Morgan, count down 1, 2, 3 and right 1. Yes, Benjamin. I mean, Noah, sorry. I just looked at the name. I mean, you are also Benjamin. Destiny, better.
It's all right. Half my teachers call me.
Mm-hmm. All right, anybody else want to show me? Yes, that is better, Morgan. All right, so our equation, let's check that first. And if you didn't get to show me, just double check and make sure that yours was right. So our equation is going to be y equals -3x plus 2. Okay, we just put the m in where the m goes and the y-intercept for the b. Then when we graph it, our starting point is 2 on the y-axis. And we are going down 1, 2, 3, and right 1. Okay. All right, our very last example today, sometimes your equations are not in slope-intercept form to start with, and we have to rearrange them. So we're going to put something in slope-intercept form, and to do that, we just have to solve for y. So this is just an equation solving. We want to get the y by itself, okay? So we've done some of this in the first chapter, but we'll practice again. Let's say that I had, for instance, 2x.
Can you go back up because my phone went dead and I had to get back on my Chromebook.
There you go. (2x plus 3y minus 12 is equal to 0. Okay. If someone said to graph this, it's not in the right form to graph it. We can't look at it and tell what the slope is. We can't look at it and see what the y-intercept is. So we've got to put it in that right form, the y equals mx plus b, to graph it. So for us to do that, we need to get the y by itself. So we want to move everything else to the other side, and we want to leave the y sitting right here. So that's got to stay, and everything else has got to go, right? So I like to move the x first, just because. So let's go ahead and move it. This x was positive, so for us to move it, we need to Subtract, thank you. So we're going to minus 2x on both sides. That's going to go away here, right? And we have 3y minus 12 equals negative 2x. We're still looking for that y. We still want to get that y by itself. So right now we can't do anything with the 3 yet until we move this 12. How are we going to move the 12? Add or subtract? We're going to add it because it was minus. Thank you. Okay, so the 12s are gone. We're getting closer to what we need. And 2x and 12 are not like terms, so we're just going to put them next to each other. Negative 2x plus 12. Does it almost look like slope-intercept form? What's the one number that's making it not in slope-intercept form that needs to go?
3.
That's 3. And it's 3 times y. So how do we get rid of times?
Divide.
Divide. So we're going to divide every single term by 3. Okay. So get rid of the 3, get rid of the 3, get rid of the 3. 3's are gone. Y equals negative 2/3 x plus 4. Okay. So we move the things that are not part of the y first off, then we divide by whatever's in front of the y at the very end. What is our starting number if we were going to graph this? We would start at 4. And then are we going up or are we going down? You can just
Down.
point. Down, right? Down 2 and right how many? 3. So if I was going to graph it, which you don't have to on your page if you don't want to, 1, 2, 3, 4, that's where I start. I go down 2, point, point, over, boop, boop, boop. Just like that. Okay. Start at the y at 4, down 2, over 3, connect my points. All right. Okay, you guys have a little bit over 25 minutes to work today. When you are writing your problems down for CUDA, you do not have to write down the ones where you're just counting slope on a graph. I'm not going to make you write your work down for that. But please show your work when you are calculating slope between two ordered pairs. Show your work when you're solving for y. Okay. So anything that you would have steps to work out, please put that on your paper.
For the ones where we're just counting slope on a graph, would we just write the number we counted?
You don't even have to write anything down on that one. You can just pick it. Okay. Yep. Okay. So everybody go ahead and log into CUDA. I'm going to turn on GoGuardian to make sure that you're doing what you're supposed to be doing. I assume everybody is.